Hi guys, the next lesson for Jones Notes is Unit 7 Energy, which is for the physical science class, which is my 6th bell. We're going to start with chapter 13, section 1, which is about work, power, and machines. So let's go ahead and get started. Part 1, so we know the definition of energy is the ability to do work, but sometimes we don't necessarily understand the definition of what work is. So it's work is done only when a force is applied to an object and then the object moves in the same direction as that force. So you apply work when you push your notebook across the table. You are applying that work, and that is actually a form of energy. So our work equation, because I know you guys like learning about all of the physics equations, is work equals the force, okay, times the distance. Okay, so I'm going to write that out real quick. So work, which is the capital W, is equal to F, which is force, times D, which is distance, which means the distance the object will move. Now, the units and the abbreviations are different. So the unit, sorry if you can hear Max drinking his water in the background. Units for work, we use joules. Which is a capital J. And then for force, you guys remember, I almost wrote force, sorry. You remember force, we used newtons, which is a capital N, times our distance. We usually, for science, we use the metric system, so we would use meters or kilometers if it was a longer distance, but typically meters. So when the work is equal to 0, okay, that means the object is not moving. Okay, so the object is not moving, the work is equal to 0. Let's say a good example of this is you might be applying a lot of force onto something and it might not move, so technically the work is 0, which is very confusing. So let's say you were trying to lift a car, but it does not move. That means that your work is 0. So you are technically not moving it. So again, that would be 0, and our work is measured in joules, so it would be 0 joules. Now, we always write the W if you're going to be really precise. The W should be in italics when writing it, so it's kind of hard to do when you're writing with your hand as opposed to typing it. But I'm going to give you a little example. So 1 joule is equal to 1 newton of force moving something 1 meter. So that's just an example for you for how it works. Let's say that I have, so my niece's name is Haley. And when she was a baby and I was throwing her in the air, so let's say this is me and I'm throwing Haley in the air. Okay, so let's say that the given force, and again, in 8th/9th grade, we don't typically calculate a lot of work, but when you get into high school physics, you guys are going to do this, so I want to show you guys. So let's say that my given force is 190 newtons, okay? And let's say that the distance that I threw her was, let's just say, 2 meters into the air, okay? I would like you guys to calculate my work. So if you guys could pause the video and see if you guys can calculate this. It shouldn't take too long. But again, we would write the formula, so work, and I'm writing it in an italic form, but it's okay if you cannot write very well like that. So we would set work equal to the 190 newtons times the 2 meters, okay? So therefore my work that I was given when trying to throw Haley up into the air would be 380 joules, and like we always do in my class, make sure we box our answers in. So that's how we would calculate work. So I hope that that is making sense to you guys. I'm going to go ahead and flip the page. We're going to do part 2 now. Okay, part 2, we are going to move on to power. And again, guys, I'm going through this. I understand you guys can't ask me questions on the spot, but if you want to shoot me a remind, I can answer any questions that you have. So the definition of power, okay, is a quantity, meaning a numerical value that we can measure. It's a quantity that measures the rate at which work is done or energy is transformed. Okay, so a lot of these things, it's like we know that they exist. It's hard to define on our own. But power just means how, like, the amount of work that is being put on an object. So if you're applying a lot of work, a lot of force, and it's moving, then you have a lot of power behind it. Let's see here. Let's say this is just a very simplistic version. But let's say I have a flight of stairs, right? And you're going to walk versus run, okay? If you run up the stairs, okay, it's not more work than walking up them, okay? Run is the same amount of work or of power as walking. Okay? So what that means is the work is the same. Okay? Work is equal. Okay? Now, what's different is the power. Okay? The power is different because it's the rate at which the work is being done. So it's the rate of the work, basically. So what I mean by that, oh, that's horrible. Hold on. The rate of work. So obviously we would know that you'd have to put a lot more power behind your body to run up the stairs than it would be to walk up the stairs. Okay? So it's the rate of the work being done. So for the power of this, your running would have more power. Sorry. And if you walked the stairs, that would be less power. Same amount of work, but a different amount of power because of the rate or the speed in which you are going. So another formula here, we have power, okay, is set equal to work divided by the time. Okay, now this is where the abbreviations and the italics become super important because it's kind of confusing. Work is measured again in joules, which we just talked about. Time we measure in seconds. Okay, power, I'm going to put a really very straight, not italic W, and that is for watts. Okay, this right here is for watts. It is not work. Watts is what we measure power in. Okay, another way to write this would be P equals W over T, which is for time, so that's our abbreviated version. So I'm going to put this right there. So we are going to give another example, okay? So let's say, so we noted that power is measured in watts, okay? 1 watt, just so you guys can kind of understand a watt a little bit better. A watt is the amount of power Now, when you guys think watt, you might think like a light bulb. That's exactly the same thing. It's the amount of power, okay, the amount of kind of force for 1 joule of work in 1 second. Okay, so just keep that in mind. That is how they got the measurement of a watt. So let's just say, okay, so let's say we have the class. Okay, so we're going to have a bunch of people. Okay, 23 of you. Okay, pulling this rope that is connected to like a pulley system connected to a car. Now I know my cars are really good. My drawings of cars are fabulous. Okay, so wow. I mean, that's maybe the best car I've ever drawn. So let's say that the car is 18. So the car's on the ground. That doesn't look like it's on the ground, but it's on the ground. And this rope from the ground to the top of the rope is 18 meters above. Okay. Now I'm going to label this as a car because I know some of you are judging my drawings, which is totally normal right here. So let's say we lift it in 20 seconds, okay? So let's find out how many watts of energy we need. Now, one thing that you guys need to keep in mind is we would be using a lot of different units here. So I'm going to write some formulas and stuff over here real quick. So 100, I'm going to write kilojoules. So we're going to talk about that in a second, divided by 20 seconds. Now, the reason why, see, I feel like I'm going to confuse you guys now. So let's say the watt, let me think how to word this to you guys. So the time is 20 seconds. So we know that power is the work divided by the time. We're going to say it's 100 kilojoules. I'm going to give that to you. Now that's because it's a car, so it has to have a lot of more energy. So that's how heavy the car is. So just understand that that is how much the car is. So I'm going to put, we are going to do 100 divided by 20. So I gave you this. So I don't want you to think I just randomly came. I'm going to give you that as that is how much the car's weight is like pulling down. So we would know that since we did kilojoules, that we would be using kilowatts. So the power would be 100 divided by 20, which you guys know is 5, and it would be kilowatts. Now, if I would have just done 100 joules, it would have been 5 watts. So all I did was, because this is so much bigger, I'm using a bigger unit. So typically we would be using joules and watts, but because the car is so heavy, we're going to use kilojoules and kilowatts. So like instead, let's say I was lifting like an apple. Okay, so if we were lifting an apple and it was 100 joules, that's like a horrible example. Let's say it's 50 joules, okay, we would do 50 joules divided by the 20 seconds, and then we would get an answer that would be in the watts and not in the kilowatts. Alright, so that is just an example. I'm not by any means going to ask you one of these questions necessarily on the review quiz. I might ask you about the formula, but you won't have to calculate anything. I just wanted you guys to be exposed to it for high school physics sake. The next section I'm going to do is about machines, and then we're going to get into potential kinetic and mechanical energy. So I'm hoping this is making sense. Let's go ahead and do the machines next. So this is part 1. Hang around, and there's probably going to be 1 or 2 more parts.